This is a TPS system that I made, and it's fully vanilla. Command blocks only, and, a smidge of redstone, but it's not too bad. And all commands that I use will be put in the description. So I'd like to run this, and what it does is it displays a TPS in chat, and it is extremely precise too. If I set the tick rate to 19.69, it will actually display 19.69. It is accurate to the hundredth of a TPS. It can sometimes be off by a smidge, but you can see I set the TPS to 20.01, and it did pick up on it occasionally. But that's how precise it is. It can also detect lag machines throughout the world, and it only uses command blocks and a clever little trick found by my friend IJ. Enjoy the video. Alright, so now I'm going to explain how the TPS system that you saw in the intro worked. It actually uses a world border command. And if I use it like this, world border set 200, you'll see that the border is right in my face here. And if I ask it to set it to 100 blocks over the course of 15 seconds, it will do so. Even when ticks are frozen, it still moves. So it's a real efficient way to get real world time. You can also use the world border get command, which tells you how far the border is. And that's actually really useful because you can put that into a score. So to make the TPS system, first thing I'm going to do is I'm going to make a new objective called TPS system. I'm going to make it a dummy criteria because I don't want it, influenced by statistics. I've already created it actually. And I'm going to put it into the sidebar here. And I've already made this system on this world before, but for the video, I'm going to rebuild it. And the first thing I'm going to demonstrate is that you can store the world border get value into a score. And you use this using execute store. And I'm going to store that into the border player in my TPS system as such. And if I set this to always active, I can get how far the world border is. Now I can also see it updating live. And it's actually a really, really accurate way of getting the real time. That's because it moves even when ticks are frozen or when the server is lagging. This was actually discovered by IJ, who is the owner of Redstoneworld. And I would like to mention that I've also built this system on Redstoneworld using command blocks. That's because the project is actually 13 years old, and I wanted a way to track lag. Because the project is so old, we have so many entities sometimes in the same spot, and I just needed a way of tracking it. And this is how I did it. So the first thing I do is I set the world border to a really large number, so 50 million, as such. Then what I do is the first command here is I'm going to set it, world get, set it to 49 million over the course of 1,000 seconds. Then I wait 48 game ticks. I find this is a good number if you want precision to the 100th of TPS. And then I store the value that I got into the border score. Just like that. So now when I run this, you see that the world border was at 49,997,601, meaning 2,399 milliseconds passed. And the reason I know it's milliseconds is because I told the border to contract by 1 million blocks over the course of 1,000 seconds. And the reason I use milliseconds and not something more precise is because Java actually internally operates on milliseconds, and that's what is used to determine how far the world border should be. Now, since I want this to be reusable, I'm going to actually set the border to 50 million after this. So 50 million. world border, yeah, no, set, uh, like that. And now you can see how many milliseconds passed using this. Actually, another thing that I'll do is because the border moved in by a certain amount, we actually want the amount of blocks that it moved by, which gives us the amount of milliseconds that happened over the course of 48 game ticks. And that's done by subtracting 50 million from the border variable. That's used using the scoreboard player's remove command. There we go. So now I'm gonna run this twice because the first time it'll kind of be broken. There we go. So you can see 2,400 milliseconds have passed, which is actually the expected amount for 48 game ticks. Since, usually Minecraft runs at 20 TPS. So the next thing I'm going to do is I'm going to have the tpscalc variable set to negative 4.8 million, and I'm going to divide negative 4.8 million by the border. So actually I'm using a mod called Better Command Block UI, and that's a very good mod which allows you to have command blocks, a lot more readable. So that's what I'm using. And here is a command that performs a division. Divide by border TPS system. So I put negative number here just because having this as negative and border as negative will yield a positive value. So I'm going to run this and you'll notice something, and that's that the TPS calc is set to 2000. That's because I'm measuring to the nearest hundredth of a TPS, and scoreboards don't support decimals. So instead of 20.00 TPS, you actually get 2000 hundredth of a TPS. So now to combat that, because I want this, let's say, displayed in chat, the first thing I want to do is copy this over to the TPS mod, which I'll do using scoreboard player's operation. Now, if you want to use the exact value for command block project, then I would copy tpscalc over to tpsint as well, so like as an integer portion of the TPS. But since I only want this displayed in chat, I'm going to use tpscalc as the integer portion of the TPS calculation, and TPS mod is a part after the decimal. So if I have like 19.45 TPS, the 45 is the mod, and the 19 is the TPS calc. So I'll start by setting a player to 100. It's currently already done, but I'll show you the command for it. That is the command to set a player called 100 to 100 points. That allows you to divide and perform modulus operations. So I'm going to execute the division for tpscalc and the modulus on tps mod. Just like that. And you'll see once I run this, I get 19.99 TPS. Now I want this displayed in chat, so what I'll do is I'll put tpscalc, so I'll have like the calculated TPS is tpscalc followed by the modulus. However, there's one small issue, and that is if the modulus is a number under 10, you'll actually need to add a 0. So what I'm going to do is if the modulus is below 10, add a 0, and if it isn't, don't add a 0. And that's done using an execute if. So if score tps mod matches 0 to 9. And then I'm going to create a telleraw, which I'll also explain. So here we go. Here's the telleraw command. The first thing I do is the calculated TPS is, and then I put the TPS calc, so the integer part, so that'd be like the 19.0 let's say 6. That's a TPS mod here. So now all you have to do is copy this and paste it, except changing some of the numbers up here. So you place a new block here, and then you remove the dot zero, the zero out of dot zero. So we go inside run this, you'll see the calculated TPS is 20.00. And just to prove this works, I will set tick rate to 20.02 and run it again. And there we go, it actually picked up on that. I can also run a lag machine. And now that that absolute behemoth of observers is running, the TPS is actually lowered. Now, as a bonus, you can actually put a redstone clock on this. Oops. 3 repeaters like this will do it. And then you can enable the clock. And another thing this is capable of detecting is TPS is over 20. So once this lag machine kind of clears out, you'll see that there is a spike in the TPS called lag compensation, where Minecraft actually attempts to compensate for lag caused earlier. So I'm just going to let this run for a bit. Okay, here we go. It's approaching the end here. And there's a spike in TPS up to 94 TPS, which is actually a lot. And we're back to 20 TPS after that. This also works with lowered tick rates. So got 19 exactly. And that's really all there is to it. You can also modify this to display this on a boss part as I did in Redstoneworld. And whatever you want. If you ever have any questions, you can ask me in the comments. And you can use this command, just before I leave, you can use this command to either show or hide the TPS system objectives, so you can use it for debugging and whatnot. But yeah, you can put questions in the comments. And now for the update on the Redstone computer. And honestly, there were lots of rendering errors when I was making the full video, and I couldn't figure out how to get rid of them. And I kind of just procrastinated. And so it never really came out, unfortunately. I will maybe at one point, try again. Uh, but I really hope to eventually get it out. And I am still working on other Redstone projects, so I am busy with those. And I hope to have more computational Redstone videos as well in the future. Anyways, I hope you all have a great day, and thank you all for watching.